Mr. Vice President, colleagues, ex-colleagues, ladies and gentlemen, it is a great honor for me to be awarded the Alexander von Humboldt Medal, and I will begin by reiterating my warmest thanks to my colleague and friend, Professor Cynthia Uvo of the University of Lund in Sweden, for preparing my nomination and giving the citation last Tuesday, and to Dimitris Koutsayanis, Enda O'Connell, Keith Bevan, and Jim Shuttleworth for giving the nomination their illustrious support. To those names of people to whom I am deeply indebted, I should like to add another. It is the name of Dr. Jim McCulloch, formerly director of the Institute of Hydrology at Wallingford, England, but long since retired. Jim is a long-standing friend to European geoscience, having been the founder editor of the Union's journal Hess, and he's been an even longer-standing friend to me from the times when we worked together in East Africa in the early 1960s. Subsequently, when Jim became director of the Institute of Hydrology at Wallingford, known by its initial letters IH, he invited me to lead its hydrological systems group. And it was through Jim that I came to know something of South America, through the Institute's involvement with UNESCO projects in Argentina and subsequently in Brazil. Also, at a critical time in my life, Jim helped me in a way which today would be unthinkable, by allowing me to take a year's unpaid leave to go and work in southern Brazil at Porto Alegre. And thus it was that my fascination with Brazil and its climate, peoples, and particularly its rivers, came eventually to form such a large part of my working and personal life. The hydrology of Brazilian rivers is, of course, on a different scale from IH's experimental catchments at Plynlimmon in Wales, for which I had also been responsible. The two Plynlimmon headwater catchments together have total area less than 20 square kilometers. The Amazon has over 7 million square kilometers, and the Orinoco almost 1 million square kilometers. So my first slide therefore shows, in homage to Alexander von Humboldt, in whose name this medal is cast, and whose award we are celebrating today. It shows the Calcareous channel, which links the Amazon drainage system to that of the Orinoco. This is the Orinoco, and this channel, the Calcareous channel, takes water from the Orinoco and leads it into the Amazon basin. Von Humboldt stood, or at least was, at this very point in the year 1800, and the landscape today must still be very much like what he saw. So we see that the Amazon basin and the Orinoco basins are in fact joined together, with flow from the Orinoco to the Amazon system via the Calcareous channel. And it is believed that perhaps 12% of Orinoco dry season flow drains to the Amazon, and that percentage increases in times of flood. Thus, Northern Hemisphere concepts such as watershed boundary, hill slope processes, first-order streams, and so on, become far less well-defined under many South American conditions. The letter from the President, Dr. Dingwall, telling me that I had been awarded the von Humboldt Medal, also said that if I wished to, I could present a medal address. And in a moment of euphoria, I agreed to do so. As the euphoria subsided, however, I began to realize the enormity of that commitment. And I began to worry about the choice of lecture topic. which topic should I choose? Some of my recent work had been concerned with anisotropy in the spatial correlation function of Amazon rainfall and its relation to ITCZ fluctuations. And that was my first thought as a possible topic. But when I began to think about that as a medal address, I was reminded of a famous remark by President Lyndon Johnson, the man who became US president after President Kennedy was assassinated. President Johnson was a Texan and had a colorful turn of phrase. And when talking on one occasion with his economic advisor, John Kenneth Galbraith, who was a professor at Harvard, mentioned that he would be giving a lecture on economic statistics at Harvard later in the day. After a pause, President Johnson said, "I guess that giving a lecture on economic statistics must be like when you pee in your trousers. It gives you a very warm feeling, but nobody else feels a damn thing." And so I thought that that might be what would happen if I spoke on anisotropy and the spatial correlation function of Amazon rainfalls, and I decided against it. Instead, I took this alternative title, A Darwinian Mystery, Fluctuations in Runoff from the La Plata Basin. It involves a little bit of history, a little bit of detective work, and a very little bit of science, and giving, I hope, an entertainment. It's a bit like one of those chocolate-covered mints which the waiter brings you at the end of a meal when he also brings you the bill as a sweetener. And in this case, the meal has been a week-long feast of serious science. So I'll be talking about the La Plata Basin, and here is this shaded area is the La Plata Basin. It involves 4 countries, Brazil, Bolivia, the whole of Paraguay, and Argentina. And it has 3 main tributaries. The La Plata is this part here, and there is the River Paraná, which flows southwestwards and then westwards, southwards. And this is joined by the River Paraguay, flowing north-south more or less through the South American subcontinent, which joins with the River Paraná near the Argentinian city of Corrientes. The third major tributary is the Uruguay, which flows in an anti-clockwise arc, joining the La Plata estuary. The River Paraná and the Uruguay have been extensively developed for hydropower generation. And more than 70% of Brazil's energy requirement is provided by hydropower, so that the occurrence of droughts is of a special importance. If there is no water in the reservoirs, you can't generate hydropower. So I shall be talking principally about some records from the River Paraná and the River Paraguay. The next slide shows the meeting of the waters of the River Paraguay, this one flowing north-south, and the River Paraná, and this shows the mixing of the waters, a phenomenon which is well known near Manaus in the Amazon, where the Solimões and the Negro rivers meet, but it is also evident here in the meeting of the rivers Paraná and Paraguay. This gives some idea of the size, the area and flow of the La Plata main tributaries, length, area, and mean annual flow. You can, in comparison with those of the Danube, and you can see that in the case of the Paraná, the largest of the rivers, the mean annual flow is about 3 times that of the Danube, and its area is about 3 times also. In the case of the Paraguay and Uruguay, They are smaller, but they are still quite significant rivers. These are given in red because I will be talking about records from the Paraná and the Paraguay. In particular, we have a record of mean discharge for the river Paraná at Corrientes, dating from 1901. For the river Paraguay at the site Ladario, we do not have records of mean discharge, but we have a record of mean monthly water level from 1900. So the first part of my talk concerns an enigmatic comment by Darwin, who sailed up the river Paraná as part of his voyage on the HMS Beagle. I would like to make a short digression talking about the Beagle. Its voyage was almost 5 years, 4 years and 9 months, from 1831 to October 1836. It's quite a small vessel, length slightly longer than a motorway lorry, rather wider in the beam, and for that 5-year period it carried 74 people, including Darwin, 65 seamen and 9 others. And it was also known as the coffin brig because of a tendency to capsize. It wasn't really a ship, it was what's called a brig because it only had 2 main square-rigged masts. A ship must have 3. One wonders what sort of young man Darwin was, because when he arrived at Bahia on the northeast of Brazil, he was aged 22, and he got there in February at the time of Carnival, which, as everybody knows, is an occasion for much drinking and music and merrymaking and mingling of the sexes. And this was what he wrote about Carnival. This day is the first of the Carnival, but nothing undaunted, we were determined to face its dangers. These dangers consist in being unmercifully pelted by wax balls full of water and being wet through by large tin squirts. We found it very difficult to maintain our dignity whilst walking through the streets, when buckets of water on each side are ready to be dashed over us. And after an hour's walking to the gauntlet, we at length reached the country, and there we were well determined to remain until it was dark. So, one feels that the response of a 22-year-old these days would be rather different. Anyway, the Beagle continued on its journey and arrived at Maldonado, near present-day Montevideo, where it was reprovisioned and repaired after its journey. And Darwin took advantage of the period of 10 days that required to go on a smaller boat up the river Paraná. And he went up to Corrientes and Santa Fe and Corrientes on the Paraná. And of course, he talked with everybody that he met, and he stayed with ranchers on their fazendas, and he learned as much as he could about the behavior of the river Paraná. And he wrote in his book, I received several vivid descriptions of the effects of a late great drought. The period included between the years 1827 and 1830 is called the Gran Seco, or the Great Drought. During this time, so little rain fell that the vegetation, even to the thistles, failed. The brooks were dried up, and the whole country assumed the appearance of a dusty high road. Then, as a footnote, he wrote, these droughts, to a certain degree, seem to be almost periodical. My underlining, I was told the dates of several others, and the intervals were about 15 years. I was very much intrigued by this remark. But he also wrote about the Paraná floods. And he says, subsequent to the drought of 1827 to 32, in the previous slide he had spoken of it as up to 1830, A very rainy season followed, which caused great floods. Hence, it is almost certain that some thousands of the skeletons of cattle and horses which had entered the river channel in their search for water and had become trapped in sediments through their weakness, were buried by the deposits of the next year. What would be the opinion of a geologist viewing such an enormous collection of bones of all kinds of animals and of all ages, thus embedded in one thick earthy mass? Would he not attribute it to a flood having swept over the surface of the land rather than to the common order of things? Well, let's have a look at what we know about the flow of the river Paraná at Corrientes. And this shows mean annual discharge for the period 1901 up to 2005. And these are natural flows, reconstituted flows, which endeavor to take account of the upstream storages used for hydropower reservoirs and the transmission of water between them and the evaporation from lake surfaces, reservoir surfaces, and so on. What stands out, perhaps, is this enormous peak in 1982, 1983, which was an El Niño event. And this shows a box plot, monthly box plot from January to December of mean monthly flows. The red spots at the top, which all exceed 3 times the interquartile deviation from the median, all arise from that 1982-1983 El Niño event. But you can see that although there is some seasonality, there are also a lot of outliers. So the flood that Darwin mentioned might have been an ENSO event, because during El Niño events, there's much less rainfall in the northeast of Brazil and much heavier rainfall in the south and southeast of Brazil, as it was in 1982-83. And this may explain the flood that Darwin reported. There's been some historical reconstruction of El Niño events by a number of agencies, those listed at the bottom. They don't agree very well about which years were El Niño events. There is one that they all agree on in 1828, but that is too early for the flood that Darwin had mentioned. But Darwin's Gran Seco of 1827 to 32, could that kind of drought occur again? Because if it did, it would have serious implications for the national economies of the countries involved. Recall Darwin's comment that the droughts to a certain degree seem to be almost periodical. I was told the dates of several others and the intervals were about 15 years. Well, that excited me, and so I went to Darwin's house in the village of Down in Kent, in England, where all his archives are stored. And I looked through his field notebooks. This is his study, and this is not a very good slide, I'm afraid, but it says Buenos Aires, spelt in the old-fashioned way with a Y instead of an I, Santa Fe, and Paraná. And this was a fascinating book to look at, because he lists all kinds of things about what he saw and who he visited. He mentions how much he spent on tobacco, to which he was strongly addicted. He mentions how much he spent on gunpowder, how much he spent on his porters. At one point, he had divided 125 by 25 and got the answer 5, unsurprisingly. And at other points, there were blood splotches where he had squashed insects. And one wonders whether one of those might have given him the disease which affected him for the rest of his life, probably Chagas disease. Anyway, I found nothing in Darwin's notebooks which helped to establish on what evidence he had based this statement of 15-year periodicity. So I tried to look at what was known about the climate of the La Plata Basin in the early 19th century. And this is a plot of sunspot activity, group sunspot number, from 1610 to 1995. It's taken from a paper by Jasper Kirkby of 2007 in Surveys of Geophysics, and it shows the Maunder minimum here, which was when oxen was alleged to have been roasted on the frozen River Thames. 1800 to 1830 or so also looks rather low. This is the Dalton minimum, about the time that Darwin was visiting the La Plata basin. And as we all know, the argument about the interaction between cosmic rays, galactic cosmic rays, and climate is a very controversial area, but one aspect of it, advanced by Svensmark and his colleagues of Copenhagen, is that when sunspot activity is low, as it was from 1800 to 1820 in the Dalton minimum, there is a weaker interplanetary magnetic field, and that results in a higher flux of cosmic rays to the Earth, which would otherwise have been, cosmic rays, if the magnetic field had been stronger, would have been diverted away. So the flux of cosmic rays to Earth is higher. There is a higher production of aerosol particles through ionization, and more cloud condensation nuclei are formed. There are other factors, for example, the clouds which are produced are low-level clouds which tend to be more reflective of energy and leading to cooler surface temperatures. And there are other factors such as the geomagnetic field of the Earth also, which complicate matters. So, well, in the words of Kirkby himself, he says that increased GCR flux appears to be associated with a cooler climate, a southerly shift of the ITCZ, and a weakening of the monsoon, whereas decreased cosmic ray flux is associated with a warmer climate, a northerly shift of the ITZ, and a strengthening of the monsoon with increased rainfall. Well, this figure is taken from Kirkby's paper, and I would like to concentrate on the two lower slides, because the lower slide shows the advance or recession of tropical Andes glaciers. In both of these graphs, B and C, the scale is inverted, so that downwards is increasing. And in this middle picture, galactic cosmic rays, these are changes in galactic cosmic rays relative to the 1950 value. These are the black vertical bars that you can see. So that you can see that there is some relationship between cosmic ray variation and the tropical Andes glaciers' growth or recession. And in particular, around about 1800, there was one rather short-lived period when glaciers advanced quite markedly, apparently, and that might be associated with this dip here in with this increase in global in galactic cosmic ray flux. But Kirkby's work of 2007 was followed last year by a further paper in Nature on the role of sulfuric acid, ammonia, and galactic cosmic rays in atmospheric aerosol nucleation, determined by the cloud experiment at CERN. And the conclusion seems to be that while the results provide some confirmation of the potential mechanism by which cosmic rays might induce cloud nucleation, they in no way demonstrate that GCRs do significantly promote cloud formation. So the relationship between cosmic ray fluxes and Darwin's story of droughts followed by floods doesn't seem to hold together very well. So I'd now like to move on to the Lodario mystery. you remember that there were mean annual water levels at Ladario and the River Paraguay for the period 1900 up to 2010. Here is here is the basin that we're concerned with, part of the River Paraguay basin. This is where it joins the Paraná. You recall that I mentioned it joined the River Paraná. And this is the site at which we have this 100 years or so of record. I would like to draw your, we have also some much shorter records from other sites. And I would like to draw your attention also to Bonito, because I want to mention that again later. Here is the corresponding picture, the box plot of mean monthly water level at Ladario. You can see that the annual cycle is much stronger. And I would like you to remember also, if you would, that over the period January to June, water levels are increasing, and from July to December, they are decreasing. And here is the picture of mean monthly water level in centimeters for the whole period. And you can see that during this 15-year period or so, from 1960 to 1975, water levels receded at Ladario. It wasn't a local effect because this shows the same thing for 6 sites in the basin of the Paraguay, all of them showing this lower period between 1960 and 1975. And this is what the River Paraguay looks like. Here is the channel, the main channel, but you can see that there's an enormous amount of overbank flow, and that is why we don't have a rating curve, a calibration between water level and river flow for Ladario. It's far too difficult to get. So there was this extended period of low flows between 1960 and 1975. And areas previously affected by extensive seasonal flooding became dry and were developed for cattle ranching. Could such extended dry periods occur again? And more important, could they also occur in the River Paraná, which has been extensively developed for hydropower production? Well, various attempts have been made to try to find physical explanations. This is one of them by a former colleague, Professor Daniel Alazia, who looked at the relationship between Ladario water levels and the Pacific decadal oscillation. And you can see that there is some agreement between the two plots, although if you calculate the correlation between the two levels, between the two values, it's quite low, the order of 0.2 or so. The question arises, can the water levels at Ladario, and indeed the flows at Corrientes on the River Paraná, be forecast? And this, my colleagues in the audience will recognize as part of the input to a very effective rainfall runoff model that they have developed, and which has been extensively used over the whole of South America. But I don't want to talk about rainfall runoff models. I want to talk about stochastic models for forecasting. Many years ago now, I had the pleasure and honor of working with a man called Clive Granger. He was at that time at the University of Nottingham, but he went on to get himself a Nobel Prize in economics. And one of the activities that he developed was for the modeling of long memory or long-term persistence. And he showed that if you take n lag1 simple autoregressive models of this form here, with different serial correlations and different variances, and add them together, then the resultant sequence, the resulting variable has long memory or long-term dependence. And so one can argue as follows, that the River Paraguay has many sub-basins, each with many hydrological elements. And if each of those is approximated as a linear reservoir, then doing some manipulation and remembering that for a linear reservoir, the storage and discharge from the reservoir are linearly related, you get exactly a lag-1 autoregression model between outflow at time t, outflow at time t minus delta t, and this as and the input multiplied by a factor as the random component. So in order to explore the use of stochastic models for forecasting of the water levels at Lodario, we took 4 families of models. A simple ARMA model, where B, as we all know, is a backward operator. B operating on xt gives xt minus, at time t minus 1. Phi and theta are polynomials. So one family of models was simple ARMA models. The second set was seasonal ARMA models involving 2 other polynomials with b raised to factor 12. These are so-called short memory models in that the serial correlation function declines quite rapidly. The last 2 families are long memory models involving a parameter d, or in this case big D and little d, which indicate the extent of the long-term persistence in data sequences. D here is related to the well-known Hurst coefficient. In the case of the ARMA model and the ARFEMA models, these were fitted to standardized monthly water levels, standardized by subtracting the monthly mean and dividing by the standard deviation. In the case of the seasonal models, that was not done, and the seasonal models were fitted to the water level sequence, monthly water level sequence as observed. Well, if we experiment with those 4 families of models, we find that there is indeed long memory. We get a Hurst coefficient of 0.835 plus or minus 0.096. And H is related to D, the model parameter, because H minus 0.5 is little d. What about the use of these models for forecasting monthly water level? Well, this is a figure that I've taken from a recent paper by Prass and other authors, and it shows root mean square errors as a function of months. Now, I must explain now what we did. In order to explore the use of these 4 families of models for forecasting, we took the period of data up to December 1990. And for that long period of record, we identified we identified the 4 families of models, which particular model within the 4 families was appropriate, that is, and we estimated the model parameters, and we used those models to forecast mean monthly water levels from January 1991 up to June 1991. Then in June 1991, we did the same again. We took the record up to that time, calibrated the models, and estimated mean monthly water levels up to December 1991. And then at 6 monthly intervals thereafter, we did the same. And we pooled the root mean square errors for the 2 forecast periods, January to June, July to December. And this is what we found. If you're forecasting only 1 month ahead, it doesn't matter which model you use. if you're forecasting more than 1 month ahead, then as long as you don't use a seasonal ARMA model, again, it doesn't matter which model you use. The two long memory models, models 1 and 2, and the simple ARMA model, model 4, all perform about equally well. What it does show, however, that root mean square errors are much higher when the hydrograph is rising than when the hydrograph is in recession. Well, I would like to speculate a little bit further about whether the Ladario low flows in the 1970s, 1960 up to 1975, could be a consequence of reduced base flow. Now this blue shaded area is the Guarani Aquifer. It's enormous. It's estimated that the volume stored in it is 38,000 cubic kilometers of water, and it provides the base flow for the rivers that feed the La Plata system. Some details of the Guarani Aquifer. It's mostly overlain by basalt. It comes to the surface, and there are areas shown here of recharge and discharge. The River Paraguay flows about here. And here we are again. I ask you to recall, to remember, if you would, this place Bonito, because Bonito is a region of calcareous rocks, and it's well known as a series, as a place where there are underground grottos with stalactites and stalagmites. Here's another picture of grottos. And it's the region of calcareous rocks which is greatly fissured and laid down in the pre-Andean Sea of Corumbá. They're almost certainly linked to the Guarani Aquifer. And because it's calcareous, it may well have sinkholes and dissolution caverns, which are typical of that kind of formation. And indeed, there are lakes like Scott Lake in Florida, which at irregular intervals seem to empty and gradually refill again. And one can speculate about whether changes in groundwater behavior and movement allied with structural changes within the fissured calcareous area have led to reduced base flow. And if so, could that happen again? And could the same physical mechanism explain both Darwin's El Gran Seco and the Ladario low floor water levels of 1960 to 1975? Well, really, we don't know. Some conclusions might be that Darwin's flood, reported on the Paraná, could be an El Niño event, but the Gran Seco, his 5-year drought between 1827 and 32, cannot be explained, nor can his 15-year period between reported droughts. Maybe that was just a loose remark by Darwin. The low water levels on the River Paraguay from 60 to 75 also cannot be explained yet. If changes in groundwater regime cause reduced base flow, then similar reductions in future cannot be ruled out. As an epilogue, I would like to pose the question, what became of HMS Beagle? You would think that HMS Beagle would be part of the British national heritage because this vessel and the man Darwin who sailed in her did more to change the way in which we think about the world and about our place in the world than probably anybody else since Galileo. In Britain, you can go and visit the the Catisac, which has just been opened by the Queen, a sailing ship which brought tea from China for several years, and that's just been restored at a cost of £70 million. However, in the case of HMS Beagle, its rotting timbers lie in the Essex marshes of eastern England. Here is England, and here is the part that is shown here. I was born and brought up at a small town on the River Blackwater here, and all of this area is, much of it is salt marsh, with winding creeks, a lot of reeds and birds, big skies and not much else. About 1850, however, HMS Beagle was brought to act as a Coast Guard station in this part. When we were boys, we cycled over this region, so we probably passed it without knowing. And it was sited there because the whole of this area was much used for smuggling from the continent. And if you look at this enlarged map, then somewhere near Paglesham here, in one of these little creeks, you will find what is left of HMS Beagle. So this is a picture of an Anglo-Saxon chieftain, Ealdorman Britnorth, and he's there just to remind me that we are at the end. So thank you for your attention.
Thank you, Professor Clarke, for this extremely interesting presentation for the Alexander von Humboldt Medal Lecture. And I would like to thank the audience for the attention, for coming here. Enjoy the rest of the conference. Thank you. You're staying here for tomorrow? Okay, for the weekend. You will enjoy practice. You have to perform.